the first one. What about the second one?
Negative 5.
Davis, how did you get negative 5? Okay, so Davis didn't use direct substitution, but he looked at it in a different way and figured out what it was approaching.
She said use direct substitution.
Okay, it's fine. It's fine. Some of the other of you? Hey, Allie, how did you get it? Interesting. You are a step ahead of me. Okay. Right now with direct substitution, we cannot plug in negative 2 because it makes our denominator 0. Okay? So we need some different techniques for finding these. Okay? Allie has actually foreshadowed what we're doing today. What?
Didn't you tell us that yesterday that was real?
Okay. I'll wait for everyone. Okay. We're going to look at 2 techniques today. Okay? The first one is exactly what Allie was talking about. If we have a rational function where direct substitution is not going to work, we can see if we can reduce the fraction at all. Okay, when we graph rational functions, we factor and then look to see if any factors canceled, and then we would graph our equation. Okay, we did a little bit of that yesterday. Same thing, if direct substitution is not going to work immediately, next see if you can actually reduce your fraction at all, okay? If our denominator, if we plug something in to make our denominator 0, 2 different things could be happening. What is one of them? There's a hole, in which case we can evaluate the limit, okay? Second case, there's an asymptote in which our limit would not exist, okay? So we need to figure out if we have a hole, do we have an asymptote. So,
We never do equations of
if there was a cubic that you would have to factor, then hopefully there would be 4 terms and it'd be able to factor by cubing. Okay? Now, until you evaluate the limit, you have to write the limit as x approaches c every single time. Until you plug that number in, you have to write the limit. Okay? So what does this factor to? Agree? Alright? So now our x plus 2's cancel, which means what? We have a hole there, and now we have the limit as x approaches negative 2 of 2x minus 1. Can we now use direct substitution? Alright, I am now evaluating our limit. I no longer have to write the limit as x approaches negative 2, because we plug in negative 2 and we get which is what Davis came up with his little method. Because we're talking about the limit. Remember, when we talk about the limit, we're approaching from both sides and getting arbitrarily close without actually being there. Okay? So let's try another one. You're going to taste exactly what you asked for. Okay. First of all, can we use direct substitution? 1 minus 1 plus 1 minus 1. Okay. Always check to see if you can use direct substitution, okay? Because you don't want to do all this work factoring and canceling out if you really don't have to. Yes.
But in this one, since the numerator is equal to 0, can't you just assume that 0 is
You can't take 0 divided by 0, though. That's illegal. You can't divide by 0.
But, like, can't you assume that 0 divided by anything is always 0?
No. Because 0 divided by 0 is undefined. And that's not okay. So our denominator is undefined if we would use direct substitution. So let's figure out, do we have a whole, do we have an asymptote? So, how do we factor that one? Yes.
You group them together, so it'd be, when you factor each group, so it'd be, once you factor, it'd be x squared times x. No, I can say.
Well, let's work through this. What do we take out first?
X squared.
Leftover is?
X.
And we take out?
1.
We take out a plus 1 and leftover is x minus 1. So we have the limit as x approaches 1 of x minus 1 over x minus 1 times x squared plus 1. So our factors cancel. We do have a whole there, and now we can evaluate our limit by direct substitution. Using direct substitution. Not 0. If you have it reduced down all the way and it still makes your denominator 0, what does that mean? That means you have an asymptote there and your limit's not going to exist. Okay? Second method we get to look at today is what we call the rationalizing technique. When you hear the word rationalize, you think of, okay, and what's inside fractions? When I say rationalize the denominator, what does that mean?
It's not a fraction.
There's no radicals. Okay? So, when we see, okay, we're going to use this technique when we have a radical getting in the way, basically, is what you're going to see. Okay? Look at this limit right here. We have a radical upstairs, first of all.
Yeah.
And our denominator, if we use direct substitution, what is it going to be? Okay, it's going to be 0. Alright? Now, it could be a whole, it could be an asymptote. Okay? So what we need to do, anytime you see something that looks like this, where you have like a radical plus a value, a radical minus a value, we're going to rationalize. Okay? Basically, I want it so that my denominator is not going to be 0 anymore. So, whatever we have as our radical plus a number or radical minus a number, we're going to multiply by the conjugate. What does conjugate mean? What's the conjugate of A plus B? A minus B. Okay? So what's the conjugate of radical x plus 1 minus 1? Radical x plus 1 plus 1. And since we're working with a fraction, we need to multiply that numerator and denominator. So we have not evaluated the limit. We still have to write it. What happens when we multiply conjugates? What is A plus B times A minus B? A squared minus B squared. So what is A squared?
X plus 1.
Minus, what is B squared? It is x,
X is canceled.
which means,
One over.
okay, hold on.
Oh, slow back down.
Okay? These cancel out right here and leave us with x. Well, we have x over x, so those can cancel.
Right.
So we have 1 over radical x plus 1.
No, that was not right. Just kidding. That's-
Okay? Can we now use direct substitution?
Yeah, we can.
When we plug in 0, what do we get?
1 over 1 plus radical 1. If you can square 1 plus 1.
Yeah.
You got it.
What?
It says 1 plus radical 1.
Okay?
What's the difference?
Anytime you see that radical plus something, radical minus something, where direct substitution is not going to work, this is your strategy. Multiply by the conjugate. Alright, so you have 2 strategies. A rationalizing technique and simplifying a rational expression so you can plug in a value. Can you handle it? Because we want to be exact. Like, if it was really 5 1/2, right, and we're not going to really have a calculator, we want to be able to do these as quick as possible. Okay. There you go.